Lesson 15.6 is about permutations. So our objective is to find the number of permutations of the elements in a set. Okay, so a permutation is an ordered arrangement. The most important thing for you to remember is that order matters here. This ordered arrangement occurs when no item is used more than once, and like I said, the order makes a difference. So here's the formula that we're going to work with today. To find the permutations of n things taken r at a time, we use this formula here. So the exclamation points you see there, that's a new symbol that maybe you haven't seen before in math. What that's called is a factorial. And I'll show some examples on the next slide, but what a factorial means is that you're multiplying together. Let's say we had 5 factorial. You're multiplying together, starting with that number, 5, and then one number less until we get down to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. Now this notation on the left-hand side, again, just means n permutations taken r at a time. This is just notation. I'll show you in class how we can also enter this into our graphing calculators so that you know where that's at. So just some quick practice with factorials before we move on to actually using the formulas and talking about permutations. So again, a factorial, 8 factorial is when we multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, we can divide factorials. You just want to think about what you would actually end up with. So 5 factorial would be 5 times 4 times 3 times 2 times 1. And 4 factorial is 4 times 3 times 2 times 1. Now in that case, 4 divided by 4 is 1, 3 divided by 3 is 1, 2 divided by 2 is 1, and 1 divided by 1 is 1. So the answer to 5 factorial divided by 4 factorial would just be 5. We can also take factorials and multiply them by a constant. So what this says is 3 times, and then 5 times 4 times 3 times 2 times 1. Okay, so here's an example of when we would use permutations. So it says, you are the coach of a Little League baseball team. There's 13 players on the team. You need to choose a batting order having 9 players. How many orders can you create? Now notice here that the order matters. Like who I have bat first and second and third and fourth, that matters. I'm not just picking 9 players and just grouping them up and I don't care who bats first. I care what the order is. So first, let's just think about this logically, and then we'll shorten this up with using the formula. So, okay, we have 9 batters. So I just kind of have these boxes here to show this is each of the batters' spots in line. Now, there's 13 players on the team. So for the first batter, I have 13 players to choose from. Then for the second batter, though, I only have 12 choices to choose from because I've already lined somebody up in the first spot. And then in the third batter, I have 11 choices, 10, 9, 8, 7, 6, 5, etc. Now, what we can do then is use our formula to get the same answer. So first of all, if I was to multiply 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5, we would get 259,459,200 batting orders. It's crazy to think about, right? That's a lot of different combinations or permutations, that we could come up with. So let's use the formula. Let me show you how you would get the same thing. So n permutations taken r at a time. The formula we learned is n factorial over n minus r factorial. So we have 13 batters and we're going to permutate them 9 at a time. So remember, we want 9 players in our batting order. So that's going to be 13 factorial over 13 minus 9 factorial. Now, we could just do this in our calculator, but let me write this out one time. So 13 factorial, I'm going to write that all one more time. 13 times 12 times 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And the reason I'm doing this is then I'm going to divide that by 13 minus 9 factorial, which is just 4 factorial, which is 4 times 3 times 2 times 1. So those would cancel, 4 divided by 4, 3 divided by 3, 2 divided by 2, 1 divided by 1. And notice here that this 13 multiplied all the way down to 5 is the same as what we did up here. So this formula will always handle this process for us. Example 3, how many permutations are there for the letters A, B, C, and D? Okay, I'm going to show the kind of longhand way one more time, and then we're going to just start hopping straight to the formula. So we have 4 letters. Now, when I choose my first letter, I can put any of those 4 letters right here. But once I choose one of those letters, then I only have 3 left to put here. And then I only have 2 left to put here, and then I only have 1 left to put here. So there's 24 permutations. Now, using the formula, which is n factorial over n minus r factorial, this would be, we have 4 letters, and we're arranging 4 of them. So we'd have 4 factorial over 4 minus 4 factorial, which is just 0 factorial. Now 0 factorial is just 1, and so we have 4 times 3 times 2 times 1 anyway, and we still get 24. How many arrangements are there for the letters of justice? So here we're going to be arranging the letters justice. There's 7 letters. Notice that none of them are repeating. We have 7 different letters. Can't write letters. Letters. There we go. Let's go straight to the formula this time. So we have 7 letters, and we're arranging 7 of them. So we're going to take 7 factorial over 7 minus 7 factorial, which is just 7 factorial over 0 factorial. Remember, 0 factorial is just 1. And so we're just going to have 7 factorial, which is 5,040 different arrangements. It's a lot, right? But remember, permutations, orders matters. So, if I have the letters in this order, if I just switch the order of the U and the J, that counts as a different arrangement. Or if I just switch the order of these two, that counts as a different arrangement. So we're going to have 5,040 different possibilities if the order matters in terms of the letters. Example 5, from a set of 9 different books, 4 are to be selected and arranged on a shelf. How many arrangements are possible? So just think of this as the same as like our Little League baseball problem, except this time we have 9 books to choose from and we're only arranging 4. So that's going to be 9 chosen 4 at a time. And so that's 9 factorial over 9 minus 4 factorial, which is 9 factorial over 5 factorial, which we can just put in our calculator, or you can think everything from 5 down would cancel. So it's just going to be 9 times 8 times 7 times 6, which is 3,024 different arrangements. Example 6, 10 people run a race. How many different ways can you get the top 3 finishers? So we have 10 runners, and we're arranging 3 of them. So it's 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial. Again, you could just use your calculator, or you could think, hey, everything from 7 down is going to cancel. So really I just have 10 times 9 times 8, and everything else will cancel with the denominator. So I have 720 ways of arranging the top 3 finishers. Okay, here's one thing that's a little bit different, and this is when we're going to use, we're going to deal with repeat elements. So it says if a set of n elements has n1 elements of one kind alike, or n2 of another kind alike, and so on, then the number of permutations of n elements is given by the following formula. Essentially, we take the number of total elements, n, so n factorial, and divide out any of the repeats. So let's usually, very common examples with this are words that have repeat letters. So it says, how many different ways can you arrange the letters of the word in? Let's start with geometry. Now notice here that we have repeats. So first of all, we have for geometry, we have a total of 8 letters, but we have repeats here. In this case, we have 2 E's. 2 E's. So what we're going to do is take 8 factorial and divide out the number of repeats, which we have 2 E's. So it's going to be 8 factorial divided by 2 factorial, which we get 20,160. Let's look at calculus. Again, the total number of letters is 8, but this time we have several repeats. We have 2 C's, we have 2 L's, and what else? 2 U's. So we're going to take the total number of letters, 8 factorial, and divide out all of the repeats, which is 2 factorial for the C's, 2 factorial for the L's, and 2 factorial for the U's. So if we divide that, we're only going to get 5,040 arrangements. Finally, let's look at Mississippi. The total number of letters is 11, but we have 4 I's that are repeating, we have 4 S's that are repeating, and 2 P's. So I'll take the total number of letters, 11 factorial, divide out 4 factorial for the I's, 4 factorial for the S's, and 2 factorial for the P's. And in that case, I'm left with 34,650 arrangements. Okay, that was lesson 15.6. Go ahead and check Schoology for your homework.